Hello everyone. Now let us continue the last example, that is second one. Laplace, we have just seen how to calculate Laplace transform of this t minus 1 ut minus 2. This answer for this is e raised to minus 2s into bracket 1 upon s square plus 1 upon s. Similarly, we have to calculate these two Laplace also. Laplace of 3 minus t ut minus 2 is equal to, again value of a is here 2 and function f of t is this attached to this unit step function 3 minus t. Now we have to apply this formula e raised to minus 2s here, Laplace of f of t plus this 2, opposite of minus 2. Now what is f of t plus 2? Just replace t by t plus 2 here in this function. Answer is 3 minus this bracket, just put bracket before minus sign, okay, t plus 2. Now simplify this, 3 minus t minus 2, 3 minus t is 1 minus t. Now take Laplace inside, we get Laplace of 1 is 1 upon s minus Laplace of t is 1 upon s square. Okay, now similarly rest of the things as it is. This one here, just replace 2 by 3 here, rest of the procedure is same. We get the answer minus e raised to minus 3s upon 1 upon s square. Okay, here function is same, just replace t by t plus 3 here. We get minus t, just minus take outside and we get this answer. Okay, now put all this Laplace in our original equation number 1. Okay, this is our original equation. Now we get Laplace transform of f of t is equal to this all values. Okay, now we have to just simplify this answer. Just take e raised to minus 2s inside to this bracket everywhere. We get this plus and minus all these things. Now we have to just take care of same terms and opposite terms. These are two same and opposite in sign. This gets cancelled, and these two are same term with same sign. That's why it gets 2 times this term and this term as it is. These are the rest final answer. Now again we can simplify this by taking outside the minimum term from this the 3 terms. E raised to minus c is everywhere and s square is also in denominator everywhere. That's why e raised to minus s upon s square is the common term from these 3 terms. What we get here 1, here minus 2, 1 e raised to minus s remains here, and here plus e raised to 2 e raised to minus 2s remains here. Okay, now if you observe this the bracket, what we get, this is a square minus 2ab plus b square. That's why it is a perfect square of a minus b bracket square. What is a term? 1. What is b term? This term, middle one. Okay, that's why it is a perfect square. This is the most simplified answer for this question. Okay, now these are some homeworks. F of t is e raised to minus t between 0 to 3 and it is 0 for t greater than t. Okay, this is one homework. Second one, let us consider the second one, which is trigonometry. F of t is equal to sin t between 0 to pi, sin 2t between pi to 2 pi, sin 3t in t greater than 2 pi. Similarly, we have to convert this into unit step function as follows. F of t is nothing but the first term, function, sin t into u of t minus this number 0 minus u of t minus this pi, plus sin second function sin 2t u t minus this lowest interval, lowest term of this interval, minus u of t upper limit, that is 2 t minus 2 pi, plus last term 3 minus sin 3t into t minus u t minus, only one limit is there, upper limit is infinity, we are skipping in infinity, only 2 pi we are writing here, u of t minus 2 pi. Okay, this is the conversion of above function into unit step function. Now we have to take Laplace on both sides. Before that we have to simplify. Just take just skip remove all the brackets by taking the term inside the bracket. Sin t into u of t minus t only, 0, skip the 0, minus sin t into this plus sin t2 into this. Now take Laplace on both sides. Here we just remove this here in this step. Laplace of f of t is equal to, now split all these terms, sin Laplace of sin t into ut minus this minus Laplace of sin t into ut minus pi plus Laplace of sin 2t into ut minus pi minus this Laplace of sin 2t into t minus 2 pi plus last term Laplace of sine 3t into ut minus 2 pi. Okay, call this our original equation 1. Now we have to find out separately these 5 Laplaces. Okay, now first, now again this is our original formula for this, for solving these Laplaces. L of f t ut minus a is nothing but e raised to minus as Laplace of f of t plus this number a. Okay, now consider first this Laplace sine t ut is nothing but sine t. We have this number a, nothing is there, that's why we are going to take a is equal to 0 here. Okay, and what is ft? Sine t. That's why I apply this formula here. What we get? E raised to minus 0. Yes, Laplace of f of t plus 0. What is e raised to minus 0? Is 1. Laplace of f of t only. What is f of t? Sine t Laplace is 1 upon s square plus 1. Standard formula. This is first Laplace we have just done. Now Laplace of sine t to ut minus pi. What is a here? Pi. What is function? F of t? Sine t. That's why I apply here formula. E raised to minus pi is Laplace of f of t plus this pi. Okay. Now this as it is, Laplace of sine, just replace t by t plus pi in the function. That's why it becomes sine t plus pi. Now we know one formula, sine pi plus theta is minus sine theta. That's why it becomes sine minus sine theta. Theta is t here. That's why take minus sign outside, e raised to minus pi s, and Laplace of simply sine is 1 upon s square plus 1. Okay, now third one. Laplace of now function becomes sine 2t, ft is sine 2t, and a is pi only. Same. Now apply this formula here. What we get? E raised to minus pi s, Laplace of function f of t plus this pi. Now apply this. What is function? Sine 2t. What is f of t plus pi? Just replace t by t plus pi here. What we get? Laplace of sine 2 t plus pi. Okay. Now multiply these two inside the bracket. What we get? Sine 2 t plus 2 pi. And we know one result. Sine 2 pi plus theta is sine theta. Also cos in somewhere, if cos is there, this is also same cos theta. Here we apply sine 2 pi plus theta is sine theta formula here. Theta is 2t here and 2 pi. Answer is sine 2t. Okay. Now what is Laplace of sine 2t? It is just 2 upon s square plus 2 square, that is 4. Standard formula. These are 3 Laplaces. Similarly, in this way also, you can solve these 2 Laplaces also. Here in this case, a is 2 pi and ft is sine 2t. So you get this answer. Here t is ft is sine 3t and a is 2 pi. Apply the same formula, you get this answer. Now we have just simplified these 5 Laplaces. Therefore our original equation is this one. Therefore put all these Laplaces in this given equation. We get the answer as Laplace transform of f of t is equal to 1 upon this, all the things we have just put in this equation number 1. Now we have to just simplify. See, first and second term has same denominator. That's why I just combine the numerator. 1 plus e raised to minus pi s upon s square plus pi plus s square plus 1 plus these two have same denominator. Just combine the numerator. E raised to minus pi s 2 times minus e raised to minus, just you can take 2 outside also, or just keep it as same, 2 times e raised to 2 pi s upon s square plus 4. And last term is just keep as it is. Okay. Now don't simplify after that, because these 3 are different terms, different with different denominators, and bigger numerator and denominator have complicated terms. That's why you don't need to solve this further. Okay. This is the question. 59th question we have just solved using unit step function. Now these are the some 2 again homeworks for you. First one is it contains sine also. So ft is 2 between 0 to pi. This is 0 between pi to 2 pi. It is sine t for t greater than 2 pi. Just solve this as it is. Okay. Now f of t is equal to this 1. This is very easiest example because it contains only constants. Okay. Now solve these 2 example as your homeworks. Now this is the point where we have just studied what is unit step function, that is Heaviside unit step function, their properties, formulas, and some examples depend on this formulas and properties. Okay, now let us consider the next point. This is a very big Laplace. First topic is very biggest topic in terms of terms and properties. That's why the inverse Laplace transform, this is which is the second chapter, which is very easy. Okay, so in this chapter there are lots of concepts, lots of terms, lots of properties, lots of definitions also. That's why this is a very bigger than the second one. Okay, now want to consider the next point, Laplace transform of the integration, where the question consists of integrations and we have to find out Laplace transform of that integration. Okay, now let us first consider the formula for this. Let f of t be the function such that Laplace of f of t is equal to phi of s. This is our original assumption for every property. Then this is the formula, Laplace transform of integration. Integrations limits are also constant for each example. It is 0 to t only. Lower limit is 0, upper limit is t. Remember that. That's why Laplace transform of this 0 to t integration f of t dt is nothing but phi of s upon s. This phi of s upon s. This is the formula. That means we don't need to solve this integration for finding out the Laplace of that integration. We just find out this phi of s and divide by s. What is phi of s? It is the Laplace transform of this function. That means whenever integration, we have to find out Laplace transform of integration, we just need to find out Laplace transform of the integrand. That means the terms in the integration sign. We have to just find out Laplace of that term using any earlier method and just divide by that answer by s. This is our formula. Okay, now let us consider some examples so that you can understand easily. Question is same, find Laplace transform of the following integration. Okay, or following functions. Number 1, 62th example is there. Integration 0 to t sin t dt. We have to find out Laplace of this integration. This is the question. Now let the whatever what we have to find, what is our first observation, what is the exact function is there and what property or what formula we have to use at the first step. What is this question consist of? Integration. That's why it is the example of Laplace transform of integration. That means we have to first write down this formula and accordingly we have to find out the Laplace of current concerned functions. Okay, now here we have to start with the assumption of a function. What is the function? We have to find out integrand of this integration. There is only sin t here. That's why let f of t be the sin t. Now we have to find out Laplace of that. That's why L of ft is equal to L of sin t is 1 upon s square plus 1. That is the original formula for Laplace. Call it as phi of s because we are going to use the formula. What is the formula? This one. Laplace transform 0 to t f of t dt is equal to phi of s upon s. Every time in each example you have to write each property in detail. Okay, or each formula in detail. This is the formula we are going to use here. That's why Laplace, our original question, Laplace transform of 0 to t sin t dt is nothing but this phi of s upon s. What is phi of s? This term 1 upon s square plus 1 divided by s. This is the only answer for this question. S is the denominator. This is the most simplified. You can directly write this, okay, instead of this. Now second one, 0 to t e raised to minus t cos 2t dt. Here function is, what is the function? We have to find out Laplace of this. Okay, question mark. Let f of t is the middle integrand of this integration, that is e raised to. First we have to find out, we have to think what is the exactly function is. It is e raised to minus t cos 2t. That means we have to use exponential property here because exponential term is there. We have to remember all the formulas. Okay, that's why what exponential property is there? This is the exponential property. L of e raised to minus at ft dt is nothing but phi of s plus a. We have already studied the exponential property, this exponential property. Okay, that means what is the original function here? Cos 2t. That's why we have to start with let f of t is equal to this cos 2t. Okay, so that we can apply exponential property here. Then we can apply our original this formula, integration formula, Laplace of integration. Now let f of t is equal to cos 2t. We have to find out Laplace of this. Therefore Laplace of cos is, whenever cos is there, numerator is yes. Remember that. Cos 2t Laplace is s upon s square plus this 2 square is 4. Call this phi of s because we are going to use exponential property here. Now write down the exponential property. L of e raised to minus at ft dt is phi of s plus a. What is phi of s plus a? Just replace s by s plus a here. What is a? This number. In this example, what is a here? 1. Okay. That's why Laplace of this e raised to minus t cos 2t becomes, by this formula, phi of s plus this number a. Okay. If minus is there, replace plus 1. If plus 1 is there, replace minus 1. This is the only exponential property we have just studied long back, okay, at the earlier only of this chapter. Now, what is phi of s plus 1? Just replace s by s plus 1 everywhere in this example. What we get then? Here s is there, replace s plus 1. Here s is there, replace s plus 1. Rest of the terms, rest of the square, cube, addition of numbers, all the things are same. Now just simplify because we are going to use again this formula for integration also. Now s numerator as it is, denominator just expand this formula, a plus b bracket square, that is a square plus 2ab, that is 2s, plus 1 square, that is 1 plus 4 is 5. Now we are going to use this formula also, integration formula. That's why we have to call it as phi of s also by using our formula. But already we have used phi of s, that's why here we have to use another notation, that means phi 1 of s. Just go on adding suffixes only. Don't use phi dash, don't use some other psi or anything else. Just suffix, go on adding suffixes. That will be the easiest way. This is phi 1 of s. Phi 1 is nothing but Laplace transform of this function, which is integrand of this integration. Now apply the formula, this our original formula. We are just learning that Laplace of integration 0 to t f of t dt is nothing but phi of s upon s. In this case, what is phi of s? This ft is Laplace. Here our ft is this, and already we call this Laplace as phi 1 of s. Therefore, instead of phi of s, here we are replace phi 1 of s upon s. This is the formula. Therefore, just divide this term by s. This is the only. This is a very easy formula. We are not going to do anything calculation. Just divide by s is the only there. That's why 1 upon s into phi of s is there. Consider next example, that is integration 0 to t sin t upon t dt. Okay, we have to find out Laplace of this integration. Let function, what is the function integrand here? Sin t upon t. That means we have to just find out this integral Laplace. What is this Laplace? Divide by t. Laplace is there. We have to remember the division by t formula here. What is division by t formula? This one. Laplace of f of t upon t is equal to integration s to infinity phi of s ds. We have already studied this formula. What is phi of s? This function's Laplace. Now here, what is our original function? Sin t is our original function. We have to start from there. That's why here first step is let f of t is equal to sin t. We have to find out Laplace of f of t is 1 upon s square plus 1, that is phi of s. Call it as phi of s because we are going to use division by t property first. Therefore, Laplace of division by t is formula. You have to write formula first, then apply this formula here. Sin t upon t is nothing but integration s to infinity phi of s is this as it is and ds. Now apply here formula. Which formula? Integration formula is there. Integration 1 upon x square plus a square formula is there. That is 1 upon a tan inverse x upon a. What is a here? 1. What is x here? Yes. That's why by that formula answer is 1 upon 1 tan inverse s upon 1. Integration from s to infinity. Therefore, now put the upper limit tan inverse infinity minus tan inverse yes only. Okay, what is tan inverse infinity? Pi by 2 minus tan inverse yes, and we know pi by 2 minus tan inverse is cot inverse yes is equal to. Now we have this is the Laplace we have just find of sin t upon t. Now we are going to use another formula, that's why I call it as phi of s, but already we have used phi of s, that's why it is phi 1 of s. Okay, go on adding only suffixes. Phi 1 of s. Now write this formula, that is our original question. Laplace transform of integration f of 0 to t f of t dt is nothing but phi of s upon s. This is the formula. What is phi of s? This f function's Laplace. Already this function is our this function. We call it as phi 1s, phi 1 of s. That's why answer for this original question, Laplace transform 0 to t sin t upon t dt is nothing but phi 1 of s upon s. Okay. What is phi 1 of s? Cot inverse s upon s. This is our answer. Now consider next example. Integration 0 to t e raised to t into sin t upon t dt. Now what is our integrand? This function. We have to find out Laplace of this whole function. What it contains? There is three functions at a time. What is it? First is exponential property. Sin t is the original function, and divided by t is also another property. But we already know, we already learned this, that if exponential property comes with the another property, we have to find first apply 1 upon t property, divided by t property first we have to find, then exponential property last. Okay, that's why let's start from the original function. Let f of t is equal to sin t. Okay, find Laplace of f of t, which is sin t Laplace is 1 upon s square plus 1. Call it as phi of s, because we are going to use which property now? Division by t property, which already we studied in this example also. Now division by t properties, we have, see, this example is similar as this example, that's why we have to just copy all these steps here also. I am not writing each and every step. You are in the assignment, in the sections, you have to copy this as it is here in between this. Okay, don't skip this step. Now directly I am writing this. Laplace of sin t upon t is this one, cot inverse s. We have just find the Laplace in this example, Laplace of sin t upon t. Now exponential property we are going to use, that's why I call it as phi 1 of s. Now write down the exponential property first. What is Laplace of e raised to at ft? Phi of s, opposite of this, minus a. What is phi of s? This function's Laplace. What is this function? Sin t upon t. What we call it as phi 1 of s. That's why answer for e raised to t, this function, into sin t upon t is nothing but this function, that is this phi 1 is there, s minus, what is a here? 1, opposite of that, minus 1. What is phi 1 of minus 1? S minus 1. Just replace s by s minus 1 here. We get cot inverse of s minus 1. Now call it as phi 2 of s, because we are again going to use the last integration Laplace, which we are just learning. Okay, that's why phi of s, phi 1 of s, next suffix is phi 2 of s. Now write down the formula for Laplace transform of integration 0 to t f of t dt is nothing but phi of s upon s. Everywhere in each property phi of s is denotation. We have to understand where is phi 1 of s, where is phi 2 of s. We have to understand that. Okay, now in this formula we are going to apply this formula here. What is phi of s? This function's Laplace. Already what is our function here? This function, and which what we call it as a Laplace of this function as phi 2 of s. That's why in this formula, instead of phi of s, we are going to use phi 2 of s upon s is the original formula. Okay, in this way only. Now phi 2 of s divided by s is nothing but divided by s only, cot inverse s minus 1 upon s. This is the answer for this question. Here are some homeworks. That is first one, 0 to t e raised to minus at minus e raised to minus bt upon t. That means here you are going to apply division by t property, then integration property. Here also t e raised to t sin 4t, Here you have to apply first multiply by t property to sign, then exponential property. We already studied this, okay? Then integration property, okay? Now here, consider this example. E raised to minus 4t is outside of this integration. And integration 0 to t sine 3t upon t dt. We have to find out Laplace of this whole function as it is. Now you observe one thing. What we have to find first? It is the exponential property we have to find. Okay. What is exponential property says? We have to find Laplace of the function which is attached to exponential. What is the function attached to this exponential? This integration. That means first we find out Laplace transform of this integration which we are learning this property, then apply the exponential property which we have already learned in the earlier topics. Okay. Now again we have to find out this integration property. Now what is the integrand? Sine 3t upon t. That means here we have to apply first division by t property also. That's why what is our original function? Sine 3t is our original function. That's why we have to start from sine t. Okay, like in mathematics, if brackets are there, so many brackets are there, what we are going to solve which bracket? The inner bracket first, then the outer bracket, then we are going to solve the outermost brackets. This is the way. Same way only, we have to first find out the original functions Laplace, then go on applying the properties whatever the example consists of. Okay. Now let f of t is equal to sine 3t. This is the original function. Now Laplace of f of t is nothing but sine 3t Laplace. What is that? 3 upon s square plus 9. Okay, this is the original formula. Call it as phi of s. Why? Because we are going to use division by t property. What is division by property? We have to write Laplace of f of t upon t is nothing but Laplace of sine 3t upon t is nothing but this is the formula s to infinity phi of s ds. Okay, this is the original formula. Now put the value of phi of s here, 3 upon 3, take 3 outside because it is constant. You can skip that function, you can skip that step. Take the constants outside of the integration or derivative anywhere. Now 1 upon s square plus 9 is there ds. What is the formula here? Same formula which we are already used this in earlier example. Okay, what is a here? 9's root 3. That's why this is 3 as it is outside. 1 upon 3 tan inverse s upon same number 3. This is the integration of this integrand. Now limits as it is, this is s to infinity. Now next step, 3 gets cancelled. Now put the upper limit, tan inverse infinity upon 3 is infinity, minus tan inverse s, put s to s only, that is s to s by 3. Now what is tan inverse infinity? Pi by 2. This is the formula, remember that. Okay. Okay, minus tan inverse s by 3. What is pi by 2 minus tan inverse? Cot inverse. Now this is the Laplace we have just calculated of this term. Okay, which is ft upon t, that is sine 3t upon t Laplace we have just find out. Now we have to apply integration property. That's why I call it as phi 1 of s. Now write down the integration property. What is integration property? Laplace of 0 to t integration f of t dt is equal to phi of s upon s. What is our phi of s now? This phi 1 of s. That's why Laplace transform of integration 0 to t sine 3t upon t dt is nothing but phi 1 s upon s. Just divide by this term by s. Cot inverse s by 3 upon s. Okay. This is the Laplace we have just find for this integration only. Now what is again? We have to apply exponential property here. Therefore, we have to call it as phi of s. We already apply denote phi of s. We already use phi 1 of also s, and now we have to use this phi 2 of s. Okay. Now write down the exponential property first. Laplace transform of e raised to minus at ft is equal to nothing but phi of s plus this number. That's why we have to apply this here. What is a here? 4. Now what is ft? This. What is its Laplace? Phi 2. Apply this formula here. What we get? Phi 2 of s plus this 4. Okay. Therefore, what is phi 2 of s plus 4? Replace just s by s plus 4 in phi 2. Therefore, it becomes cot inverse of s by s plus 4 upon 3 as it is upon s, that is s plus 4. You can write it as this way also. Okay, this is the answer for disintegration and exponential property. Here in exam also they will ask the most complicated terms, that means where more than one property can be used, where exponential is there, division by t is there, sometimes exponential there is there, multiply by t. Okay, sometimes here integration also. Okay, this is the, you have to just observe the example and first go on calculating the most inner ones Laplace, then go on adding the properties and those things. Okay.